Thank you so much. I'm very excited to be here. Thank you for the invitation. So, before we start, the topic today is Web3, the context or the concept of decentralized autonomous organizations in Web3 and how it intersects with AI. But before we get into that last question of how it intersects with AI, I would like to ask you who here could describe Web3 to your neighbor in a sentence or two? Show of hands? No. Who could explain the concept of a blockchain network to someone else? A few people, maybe 2, 3, 4. Okay. Who has played around cryptocurrencies, owned some, received some? Okay, not too many, but much more. These things are all interrelated. Unfortunately, we don't understand it quite yet. Yeah. Can I ask for the timer to go on so I can see? I'd like to not go over time. Thank you. All right. So before we can speak about the concept of Web3, we have to go back in history and understand how the internet started. So if we go back in time, 1990, who remembers the early days of the internet? Show of hands? That's my last question. Okay, a third. So I would assume a lot of you were born sometime in the 90s and you already grow up with the internet. But for those who haven't, the internet was actually quite the interesting thing that we couldn't understand in the early 1990s. We had computers. Most people didn't have computers. Some had them at home, some had them at work, but they were not connected. So, even if they were connected, most people couldn't use the internet because the user experience was really bad. And that all changed early 1990s with the emergence of the World Wide Web. We could create websites with a few lines of code, but then people didn't know what to write on this website. And then other people could use these websites and click on a link and get information from another computer, and that was quite revolutionary, but it was hard to understand. And I would like to ask you to watch this video with me from 1994. We will need a few minutes until it comes up.
Like that, as I was doing that little tease.
Oh, that's
that little
right.
mark with the A and then the ring around it.
At?
See, that's what I said.
Mm-hmm.
Katie said she thought it was about.
Yeah. Oh.
But I'd never heard it.
Around
I'd never heard it said. I'd always seen the mark, but never heard it said. And then it sounded stupid when I said it. Violence at NBC.
What would be around or about in the lunchroom the other
See,
week?
there it is. Violence at NBC. GE com. I mean.
Well, Allison should know.
What is internet anyway?
Internet is that
massive computer network.
The one that's becoming really big now.
What do you mean? That's big. How does one? What do you write to it like mail?
No, a lot of people use it and communicate. I guess they can communicate with NBC writers and producers. Allison, can you explain what internet is?
No, she can't say anything in 10 seconds or less.
Oh, Allison will be in the studio shortly.
What does it mean?
It's a giant computer network made up of started from.
Oh, I thought you were going to tell us what this was.
It's like a computer billboard.
It's not a. It's a computer billboard, but it's nationwide, and it's several universities and everything all joined together.
Right.
And others can access it.
Right.
And it's getting bigger and bigger all the time.
It came in really handy during the quake. A lot of people, that's how they were communicating out to tell family and loved ones they were okay because all the phone lines were down.
I was telling Katie another
time. But you don't need that. You don't need a phone line to operate internet.
No.
Well, that was 1994 or 5. That was the very early days of the internet, and we called it Information Data Highway because it allowed us to get information in an electronic way without having to travel somewhere else. And the first application of this kind of World Wide Web or this early generation internet that most people used was email. So most people understood email, but they didn't understand websites. And it took us around 10 years to understand what we could do with a website, that we could not only write information on the website and click on links and retrieve information from other websites, but that we could use these websites to do much more powerful things. And as we figured this out, and it took us around 10 years, what emerged were more powerful websites, these internet platforms around social media, e-commerce platforms, knowledge platforms such as Wikipedia, that brought a community of people together around their platforms that exchanged information, such as Wikipedia, Quora, etc., that exchanged goods and services on eBay, Amazon, etc., and that exchanged information, experiences around social media. So what the Web 2 brought us was these distributed internet tribes that were centrally managed around those platforms that are still, until today, privately owned. And in that sense, Web 3 is this next generation internet that takes these distributed internet tribes to the next level, or to the back end of the internet, and allows them to collectively contribute to internet infrastructure as decentralized autonomous organizations. So in Web 3, we are reinventing really how the internet works. We're collectively maintaining kind of this infrastructural components in the back end, and the main applications are the tokens. Some refer to them as cryptocurrencies, but we'll get back to that in a second. So just to zoom in on the difference of Web 2 and Web 3 for all those who use the internet but don't really work how it works, or don't really know how it works. So as a user, current internet is very much based on the principle of client-server technology, where you have a set of computers that are connected via a communication protocol with each other. This is what we call the internet, or another metaphor is the cloud. And in this internet, you always have a client, a computer or a mobile phone, a mini computer that kind of has an application that retrieves information from another computer server that offers an internet service. Facebook, Twitter, Instagram, your bank, Amazon, YouTube, any Snapchat, any type of mobile or internet-based service that you consume is provided by usually private companies, or at least, even if it's public organizations, these services on a technical level are provided by privately managed computer infrastructure servers or a set of servers. Now, in Web 3, the game-changing aspect here is that data is more and more collectively managed by peer-to-peer networks of computers, where the people who collectively manage this computer infrastructure or internet infrastructure might not know each other, live in different countries, and the backbone of this peer-to-peer cloud, this distributed kind of internet, are blockchain networks, and they manage the state of all tokens in the network, who owns which tokens and who sent which tokens to whom, but in an anonymous or pseudonymous way at least. Blockchain networks are the backbone of this Web 3, but we need other peer-to-peer networks that operate or that provide other computing tasks, such as file sharing, peer-to-peer file sharing networks, metadatabases, peer-to-peer metadatabases, etc. In the front end, your user experience really doesn't change. You use your computer or your mobile phone, but the difference is that the application on your phone has a component we call the wallet. It's a blockchain client that kind of identifies you over public-private key infrastructure, has a unique blockchain address, and you can manage all your tokens through that wallet and perform all operations in this peer-to-peer cloud over your wallet. Now, most of you probably heard of Bitcoin, cryptocurrencies, Ethereum, crypto assets. These are in my opinion, very similar. It's like the first application of Web3, very similar to email. That was the first application in this emerging internet in the early 1990s. It's the first application, but it's not the only thing we can do in Web3. It's just the first thing we're starting to understand. Tokens can represent something like a currency or a crypto commodity, or they can represent some kind of property right of a physical asset, but they can represent also many other things. Web3 tokens or crypto tokens are basically, it's a very versatile rights management tool. And it's a simple smart contract, a piece of code that defines which rights you have with that token. And these rights could represent ownership rights, access rights, voting rights, management rights, all different kinds of rights. They could be tied to the same token under specific conditions, or they could be represented by different types of tokens, depending on the token system and the decentralized organization you're part of. These tokens, these smart contracts, unfortunately, they're not very smart. The name is a bit unfortunate. It's a piece of code that is collectively managed by a public blockchain infrastructure, by all computers that verify the transactions in the network. And they represent these different rights. And as a user, you need an application on your mobile phone that also has wallet capabilities that can communicate with a blockchain network. But as I said, these tokens are just one application. They can represent different things, but think of these tokens as the fuel of this new distributed internet. And this distributed internet is organized in a completely new way in the form of decentralized autonomous organizations. And why do these kind of distributed internet tribes, I also like to call them, differ from how our current systems are organized, computer systems or organizations, and internet-based systems? Usually you have a private company or a public organization managing, for example, a website or actually any type of company, and you have some form of top-down management. You have a company that is registered somewhere, and people have legal contracts with each other. There are employment contracts, there are legal contracts that the company has with other companies, or the company has with their clients. If you use social media, you can't just use it, you have to agree to the terms and conditions of using their networks, sharing your data with them, and what you get for free. Usually we don't read them. Few people read the terms and conditions, but it's a contract that you sign before you can start using any type of social media network. And then if something happens, if something goes wrong, if someone within the organization doesn't stick to their end of the bargain, you can use the rule of law, you can use the legal system to sue, for example, your company for not getting paid, and to, for example, sue a company for data privacy breaches, et cetera, et cetera. In Web3, we have a completely new way of organizing ourselves. And while we reduce, for example, Bitcoin to the token, the Bitcoin token is a token, but it's also a distributed network that is maintained by people that live in different countries, that don't know each other, that don't have legal contracts with each other, that operate with each other over a computer protocol. And this computer protocol defines who in the network is allowed to validate transactions, send tokens, who is allowed to do what and when, and how you might be incentivized to contribute to the network. If you, for example, download the protocol and start contributing security services and verifying transactions in a blockchain network, such as a Bitcoin network, you can start earning Bitcoin tokens, the currency of this distributed internet tribe, for performing computer operations in this network. And so while Bitcoin is a cryptocurrency, it is first and foremost a collectively maintained public infrastructure in the absence of legal contracts and only based on a computer protocol and smart contracts where it's predefined who is allowed to do what and when. These distributed internet tribes resemble nation states much more than they resemble companies. They have their, they usually have their own currency, at least one. Sometimes they have more than one internal currencies, and they're distributed networks over the internet. They're economic systems, but they're also social systems, because the computer nodes are not fully automated. They're operated by people or institutions that hold these wallets. And as such, as I said, they resemble nation states. The dynamics of how it works, the economic logic of how network actors are steered is very much influenced by kind of issuing a currency, by macroeconomics, microeconomics, and how you would steer a nation state. But as opposed to nation states, they're kind of single infrastructure nation states. The Bitcoin network is a public payment network over the internet that is collectively maintained in the absence of banks. The Ethereum network is a public computing infrastructure upon which you can build any type of smart contract that represents any type of token, and that token can represent any type of rights and or even a kind of decentralized organization on top of the Ethereum network. How does this work? Oh. There is something wrong with the slides, and I don't know. Okay, something went wrong. I have to improvise here because something got lost. So, yeah. Basically, the computer protocol defines the rules of who is allowed to do when and what. And you can think of this computer protocol as a computational constitution. This is automatically enforced by all computer nodes that downloaded the protocol. And then the people participating in this network, and it doesn't have to be a blockchain network. We have Steemit, a decentralized social network over Web3, where you can own network tokens for contributing posts to that social network, and people actually used to make money with that. It's become less popular. You have Helium, a decentralized telecommunication network where you can put antennas in your homes and start earning network tokens, Helium tokens, for providing telecommunications services for a LoRaWAN network. These things already exist, but most people don't know about it yet, so the user base is still small. And so you can earn these tokens. The rights of who is allowed to do what and when in the network are encoded in this computational constitution. And you can participate or not participate. And there is this feedback loop of what you're allowed to do and what you choose to do as a human kind of human stakeholder in the system via your computers. You participate via your computers. And you can also, these systems, they don't have owners. They're collectively maintained. So if a lot of people in this network decide that they want to change the rules to, for example, Bitcoin, for example, to make Bitcoin transactions faster or more environmentally friendly, we had that in the case of the Ethereum network. They changed their consensus protocol to have a smaller CO2 impact than, for example, the previous way of verifying transactions. And in order to change the network rules, everyone in the Ethereum network had to participate over the vote of how to upgrade the protocol rules. Obviously, there were some experts that decided over the options of how to upgrade these protocol rules. But everyone who runs an Ethereum node could participate in this decision-making process. So and unfortunately, we don't see it here because I had this feedback loop, which we don't see, of the computational constitution, what can be automatically kind of everything that is automatically enforced. And when a critical mass of network members decide that they want to change the rules, they have to come together, discuss in person, well, usually not in person, over social media networks, of the possibilities of changing the network rules, of who is allowed to do when and what, and who gets how many networks tokens for doing what. And then eventually, if there is a perspective on the horizon that most people would agree to a specific protocol upgrades, these protocol rules are then voted upon. And then if the majority that is big enough decides to upgrade these rules, the network will be upgraded to the new rules, and you have this new computational constitution. So you have the feedback loop between humans and the machine protocol, and the kind of human, the computational constitution, and the computational enforcement of the governance rules, and the human governance aspects of how should we upgrade these systems. And what I wanted to show in this last slides that we see here is where, for example, AI would come into importance in this human-machine feedback loop of these decentralized organizations. Because we could put these smart contracts, as I said, they're not very smart. The rules are quite rigid of what you're allowed to do or not, or the computers are allowed to do or not allowed to do. And the rules can only be upgraded with the human feedback mechanism when enough people in the system decide that they want to change it. However, we could equip these smart contracts that are not actually very smart with more intelligent algorithms, eventually with AGIs, to assist this feedback mechanisms within a certain range of the purpose of the specific network. We could also use AGIs at the end nodes to have AI-assisted governance. So before I make a decision, instead of only using my brain, I can use an AI to help me with the decision process, because I might not be an expert in blockchain protocols. And the third part where AGIs can come into play is that at the end nodes of these decentralized organizations, such as blockchain networks, we don't always have humans. We have humans operating machines, and we can automate these machines via bots. So we have that in the Bitcoin network, we have that in the Steemit network with the social media bots that were generated, and we have that in many other DAOs. And these bots are not very smart at the moment, but if these bots come equipped with more intelligent capabilities, if these bots are independent economic entities and might even in the future have their own legal entity, they might become independent economic players in this man-machine interactions of humans and kind of blockchain protocols. So this is the future. The technology doesn't come in isolation. AI is one emerging technology. Blockchain networks, Web3, are another emerging technology. We have many other emerging technologies, and when they come together, this is when these systems can become very powerful. Think of everything that was presented to you yesterday and also today. What if we can equip, for example, an AGI? What if we can give it DAO capabilities? This AGI as a wallet, it can become an independent economic actor in a decentralized organization interacting with humans. And this is where this future, kind of the future gets closer together between the different emerging technologies that we're speaking about today. Thank you for your attendance.